The world I'm living in comes in three pieces, or this part of the world, and it's BGP security. The first piece is the infrastructure you need to support BGP security, and that's the RPKI, okay, the Resource Public Key Infrastructure, and I'll spend some time describing that. Then, given that substrate, we build two things on top of it. The first one, which we'll do today and do with the hands-on lab, is route origin validation. Did that AS have the authority to announce that prefix? Trying to shoot the YouTube incident. The second thing, which I have a presentation on Tuesday in plenary, is path validation, BGP path validation, which amounts to preventing the Capella Pilosof attack, monkey in the middle on the path. Okay? So, okay, come on now. That should work, right? Well, it doesn't. Does this work? So, today is little x509. I hope you all know it because I don't have very good material on that. The RPKI and origin validation. This is about a 40-minute talk. Then we're going to hand the hands-on lab with a GUI and Juniper and Cisco routers. Then, 5 minutes on the status of various implementations. And then Tuesday, or then if we want, we can build the RPKI software. Tuesday, I'll give a talk on path validation. Okay? So, this subject is not new. In '86, Steve Bellevin published a paper that said the two big holes in the internet are DNSSEC, or DNS, there was no such thing as DNSSEC then, and routing security. In '99, Steve Kent and Charlie Lin, who has since died, and others at BBN did something called SBGP, Secure BGP, which had some serious weaknesses in design, but was the first serious proposal. Another proposal came out after that called SOBGP, and I'm not going to go very deeply into that. In 2003, we had a workshop with a prototype implementation of SBGP in Eugene, Oregon. Then there was 5 years of war in the ITF between SOBGP and SBGP. Totally non-productive. Nothing was learned. Okay? In 2004, a bunch of us, 2006, a bunch of us crawled in the corner, about 20 of us, and did a design of this resource public key infrastructure, and then later did origin validation and then BGP-SEC development. In 2009, ISOC discovered the problem and held a workshop on it. Okay, so again, the design was done outside the ITF of the RPKI and then brought into the ITF in 2008. Okay, and it's in the CIDR working group. The chairs of the CIDR working group are here. You're encouraged to participate and all the usual IETF wonderful things. It's open and all that, if you can read a whole lot. 2009, the CIDR working group using the RPKI started working on origin validation. Okay, 2008, we started another outside of the ITF design team on what I'll present Tuesday, BGP-SEC, and that was dumped into the ITF in last March in Prague. So all this is now in the ITF, churning around. Some of it's very close to the RPKI stuff's very close to being RFCs, etc. And you've survived the first slide deck. So, you are welcome to, by the way, interrupt me, continue the discussion, anything. We've got more time than we need. So there's a whole bunch of people who've worked on this, RPKI stuff. The ones who are hanging around here is I've done a bunch of the architecture, Rob Austein has too, and a bunch of others. And Rob's here. Steve Bellevin, who's upstairs working on a paper. Michael Elkins, who's done all the GUI stuff, and lots of other folk. Still not getting this working. What the heck? Okay. The basic problem is routing is very fragile. As Jonathan Zittrain said at TED Talk, the web is surviving by random acts of kindness. When the YouTube incident happened, everybody remembers the YouTube incident, right? I can presume that, when Pakistan made a little slip and announced YouTube's prefix to the world, and there was a big sucking sound. How did it get immediately fixed? Somebody posted to Nanog, and we all hacked on our routers. And that's random act of kindness. That's what Jonathan meant. 99% of misannouncements are accidental originations of somebody else's prefix. We call them hijacking, but they're really fat fingers. Okay? Nobody really means it. So what we want to do with origin validation is prevent the YouTube incident. The origin of the prefix was not the right AS. Okay? In about 97, AS 7007, for those of us who aren't old enough, I wish I wasn't, took their entire BGP table, redistributed it into RIP. Now, Mommy always told you, do not redistribute BGP into IGP. He then, RIP, of course, sliced it into /24s. And then he redistributed it back into BGP. All 65,000 prefixes. The routers weren't prepared to handle it at that time. It was still being cleaned out of corners of the internet 2 days later. And by that, I mean, it just took Sprint and UUNet down for hours, et cetera. It was a major disaster. If it happened today, we would be spending a lot of time explaining ourselves to funny people who wear suits that we really don't want to explain it to. There was another one in, about that time, I don't remember, where somebody in a lab, Cisco was wanting to test putting the forwarding table in the line cards. And so they made a little command that was supposed to be Cisco internal only that said, hey, generate all the 24s in 128/9. That's 32,000 of them. And so it could fill the line card with stuff. Somebody accidentally typed that on a live router on the internet. Days went down. Again, took all the big networks down. So what we'd like to do is prevent these accidental announcements. What we're not going to try to do is prevent malicious path attacks, such as Tony and Alex took and stole the DEF CON network right out from under DEF CON by altering the path and trapping the traffic, et cetera, et cetera. Tony's here, and he can describe the attack to you. It's very well known. That's going to require validating the AS path and locking the data plane to the control plane. So that's going to be a talk on Tuesday. So we're just trying to prevent the accidental ones that are taking us down on a daily basis. So our goal is to keep the internet working, to reduce routing damage from misconfiguration and misorigination. The non-goals are to prevent malicious attacks, and the non-goal is to not keep the RIRs in business selling us certificates. So there's a resource public key infrastructure. Anybody here not understand public-private keys? Everybody gets public-private keys, X509, PGP? Yes, cool. Bump, 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 bump. Okay, so there's this PKI, this public key infrastructure being developed and deployed by IANA, the RIRs, operators, et cetera, and I will now bore you with it. takes an X509 certificate, and RFC 3779 extends X509 by a valid extension to allow a certificate to describe a set of IP addresses and AS numbers. Yes, IPv4 or IPv6. Okay? Everything else is pretty much the same. So that a certificate, for instance, from Aaron, could describe this /16, though of course Aaron really has much more in their certificate. And Aaron could allocate, or whatever the verb is that's politically proper to use this week for delegating some address space to a member, customer, legacy, or whoever, could give a /20 to ISC, could give another /20 out of that 16 to RGNet, another to PSGNet. This could, it's turtles all the way down. It starts at the IANA, just like BGP sec does. But today, the IANA is not playing yet, so this is what you'll find. You'll find Aaron actually has a certificate they've self-generated for all their address space they control, and then you can start playing in their space and generating your certificates. That says who owns it. But who has the right to announce it? What AS can announce that prefix? It's called another object that's in the RPKI. It is not a certificate, and this is a key point. That's called a route origin authorization. We're going to call it a ROA from here on out because I can never remember that phrase. Okay? So say this entity owns these two chunks of address space. Okay? So they want to let this one, the 98, be announced by AS42. They don't want to let this be announced by AS42. So they make what's called an end entity cert. This certificate cannot sign other certificates. It can sign random blobs. Certificates that have the CA bit on cannot sign random blobs. So this is why there's this arm's length transaction. And it says, hey, take this, make this EE cert just for the 98, and now this signs a ROA with its private key saying 98.128/16 can be announced by AS42. AS42 does not have to sign and agree to this. AS42 agrees to it by actually announcing the prefix. Okay? It doesn't have to announce it. And in fact, what will happen is, if I'm going to switch providers or something like that, and I own this address space, I might have both ROAs outstanding at the same time. And use make before break to switch the circuit over. So, I'm sure everybody who reads Nanog for the last couple of years remember when I conducted an experiment where I did AS path poisoning. And 98.128.16 was actually the prefix I used with my own AS, but I used other ASs in the past. And because of route flap damping, I wanted the experiment to terminate in some reasonable amount of time. And so I announced all 256/24s of it. If I had to issue these ROAs, it would have been disgusting, right? Just a miserably long amount of them, 256 of them, and what a silly mess. Why do that when you can have a macro? So ROAs have this little macro trick where they say 98.128.0016 can be sliced up as small as /24. It's called max len, maximum length. Okey-doke. So, how do I use this in reality? In reality, I have a /16. I'm an ISP. I use that 16 in 4 basic ways. One of them is my infrastructure, my point-to-point links. Can you actually hit that thing? No. My point-to-point links. Some are my static customers, okay? They're not BGP speakers, they're just static customers. 3 of them in this case are BGP speakers, and there's the stuff I haven't used yet. Now, I don't want somebody to be able to punch a hole here or punch a hole here, okay? So, the man. So, I make a ROA for the whole 16 to my AS. So that means nobody can announce this 24 from their AS, because the ROA says, nope, it's Randy's AS. But oops, these guys are announcing pieces of it. So before I do this, I really should help my customers, BGP-speaking customers, announce their pieces as issuing ROAs so that they don't get hit. Okay? So they have ROAs for theirs, and I have one customer here who says, I don't want to know what a ROA is, move my bloody packets and shut up, that's what I pay you for. And I provision their certificate structure just like I do for provision their circuits, do their inatter.arpa, whatever it is, it's part of the game and they pay me for it. So, that's the theory of the infrastructure. How do these get generated, handed around? How do they get to my routers, which is where I want them in the long run? Okay, the first thing is there's a certificate engine which can generate certificates for things. I have a certificate from my parent. For instance, Aaron has one from the IANA. So the IANA publishes a certificate for Aaron. Aaron has a certificate engine and publishes certificates for its children. And its children can have certificate engines and publish for their children. Okay? And anybody who has a certificate engine has some back end. This is currently your Oracle database or Excel spreadsheet or whatever, where you track your IP and ASN resources and your customers. Okay? So this talks to this, and they talk up and down the address allocation hierarchy. Now, if you're not really interested, you're not a big ISP, you don't want to play this game, your parent, the place you get an address at your address space, will actually just let you do it via GUI. And I'll show you that in a second. I just want to decompose the certificate machinery. And there's the signing certificate issuing engine that takes this loop and makes XML objects, wraps them in CMS, and pushes them up and down to parents and children. There might be a hardware signing module on the side, and this is your back end, and there's an internal protocol. Okay? And the trick that we're going to use in a minute is there's also a publication protocol so that your engine can publish the certificate it issues in a publicly available part of the PKI. The resource PKI, you'll publish the certificates you issue for IP space, ASNs, and route origin authorizations. Okay? So, this is not what happens. On the internet, we do not believe in big, centralized, and scary. Unless you like OpenFlow. Then those people can have a centralized database. They seem to like centralization. What really happens is the IANA has when IANA issues space to APNIC, it creates APNIC says, give me my space, issue a certificate for my space, please, and I will publish my certificates here. So IANA makes a certificate for APNIC, which it stores here, and that certificate has what's known as an SIA pointer to where APNIC publishes. And IIJ comes under APNIC, and ARIN has UUNet, and PSGNet has legacy space from both of them, and so on down the chain. Okay? So everybody who runs an engine, and think of running an RPKI engine kind of on the scale of who chooses to run an IRR instance today, right? Level 3, whatever UUNet's calling itself this week, so on and so forth, NTT. So think of running one of these instances as, you know, there's going to be 100 in the world. Somewhere's on the order of that. That's still, how do I gather? I want to get a validated cache, because when some new person calls me up and says, I want to be your customer, I own prefix 343434, do they or don't they? I want my NOC to be able to look it up. Just type in, who owns this? And they have to produce the private key to match the public key, et cetera, et cetera. Just like DNSSEC, you have a trust anchor. That trust anchor is the public key of the IANA and a pointer to where IANA publishes. And you can go there, and you can go there, okay, and you can slurp all of this into an untrusted directory, and then you can take the trust anchor and you can start at the top certificate and go down through it and get all the certificates that have proper expirations and signed by the parent, etc., and gather all the valid certificates from the IANA and put them here. And then take any of them that point further downwards, grab that, stick it here, validate it, stick it there. You descend through this entire mess, gathering certificates and ROAs from all over the internet, and soon you have a totally validated cache. Okay? But there are two problems with that. One is that could be a lot of fetching. And two is, you know, for example, who is our GNet? And when I go to fetch the stuff, which I probably won't want to do every half a day or something, how do I know are they going to be reliable enough to keep a server up? So there's scaling issues here that we would like to ameliorate. And that's where, if you remember, the publication protocol comes in. I, who is running a certification engine, can contract out with a third party to publish for me. And I use the publication protocol to publish on their infrastructure, on their disk infrastructure, on their server infrastructure. Say they've got, you know, a 10-server Anycast infrastructure for this or something. Right? So I don't have to guarantee to be up 7 by 24 by 3 easily. Can we have a manual mic? Oh, here's one right here.
Can you publish for yourself as a backup, as long as in addition to the people
okay.
you?
The short answer is no. The long answer is we should be able to design something that has the reliability of the DNS with the Anycast stuff and multiple A records, et cetera, where you could do that. That's not in the base design. The publication protocol does not have forking and replication in the base design.
Randy, a minute ago you said that building the local cache would be an awful lot of fetching because you'd have to chase an awful lot of chains for a lot of prefixes. once you've done it the first time, it wouldn't change all that terribly much.
What is used here, by the way, is the rsync protocol.
Yeah. So,
The protocol, by the way, this fetching protocol uses rsync to grab that. And when it gets it here, since it's validating, it's kind of cynical. So we call this overall, we call it arsenic. Sorry. So the publication's hosted. And maybe what we're going to find is 3 or 4 biggies, not ISPs necessarily. So maybe Google decides to be generous and builds a global publication infrastructure that we could all use. They won't, because unlike stealing and recording all our DNS queries, this one won't tell them how to better sell ads. But there are some approaches that could be used to scale this up with a public infrastructure. Okay? The usage scenario, as I said, is more like, I'm an RIR, I'm Aaron. 98% of Aaron's members do not want to run their own certification engine. They don't want to do any of this. They just want to log on to Aaron's website, My Aaron, or whatever the heck it's called, just like they do today, and say, see this prefix? Let that AS announce it. So Aaron will have a web GUI front end for them to use, and that'll take care of 98% of Aaron's users. 10% of the address space is represented by those 98% of the users. This is fallen, I'm told. Oh no, he's just dimming it down every time I walk by that speaker, I think. Smart guy on the rheostat there. Oops, rheostat's a very dated term. What is it called today? Potentiometer. I don't know. So anyway, 2% of the Aaron's members own 90% of the address space. That 2% are down here, and they'll run their own engines talking to Aaron over the up-down protocol. Okay? So Aaron will have, or let this be you instead of Aaron. Your NTT, your Heasley sitting over there. And so Heasley's address management group, Vipar is it? Will muck around with resources and allocate things to people that will drive their Cert and ROA engine. Their users who are small can type into this. They have some large users who will run their own. And NTT publishes over here at a nice publication point that GUI only that Google runs, and if somebody clicks on 35 ads a day, you can use it for free. Okay? And that's kind of the common envisioned usage scenario. Okay. So, what I'm going to do now is take that infrastructure and show you how we use it to do origin validation. And it's in iOS, their test code in iOS, iOS XR, Juniper. Everybody's doing it. The cute thing is, and what this slide is about, is currently, if you want, I'm sorry, I've got to stop that. If I want to, I don't mean it. If I want to filter my peer today, I've got to do a big fat ACL, and it's costly. Costly in terms of time, because the router has to go through a try, or worst comes to worst, a list, and test it. In an implementation that runs today on a 12,000, Cisco 12,000, the data goes directly into the prefix try, and it's a constant 10 microsecond cost to validate a prefix. In other words, this stuff is faster than access lists. There are other modes of using it than having the router do it automatically, of course. As I said, you could gather a cache once or twice a day in your NOC, have a nice little GUI so that your knockers can say, when somebody calls up and says, that's my prefix over there, stomp on it, somebody else's, they can look it up and see if that's true. And by true, we mean cryptographically signed all the way up to the IANA. Okay, we don't mean in the IRR and God knows who put the crap in there. Okay, so high speed, you can use it. Oh God, I forgot to add that slide. The software that's doing this is also doing a cute thing that we don't show here, is it's generating, oh no, it's the arsenic that's doing it. So this gatherer who's gathering a validated cache also produces optionally a pretty web page telling you the status of everything. It also produces optionally a list of route and route 6 objects in IRR RPSL format. So if your existing software is based on RPSL, you can put this pseudo IRR on the front of the other IRRs, and you will have ROA validated crypto generated route objects. So that you can, and this was done for Rudiger Volk of DTAG, so that you can have your existing software untouched that is based on RT config or whatever, do this for you using IRR style data. Sorry for the digression. So let's say we have the global RPKI scattered all over the internet. We have the arsenic gatherer gathering a cache. That cache is in or near my prop. We run something on the cache server that also comes with it at no extra charge, called the RPKI to router protocol, which is designed to take the RPKI data and produce for the router a list of pre-digested stuff that is the minimal information the router needs to know, so that this should be able to run on current routers. And we will do so this afternoon. And why I say near in the POP is here we have object security. We can check the certs all the way up to the IANA, etc. This lady doesn't want to touch certs. Too expensive, too big right now. So this is in your POP. This is trusted. You own this. So this protocol has no content that is validatable. You trust that cache. And the protocol kind of looks like this. A typical exchange is the router says, "Good morning, I just woke up. I want to reset the world." And the cache says, "Cool, I've got a bunch of stuff. Here it is, a bunch of prefixes," and we'll go into detail on what the V4 and V6 payloads are. Gives it the entire list of everything that's in the database and says, "End of data." For those of you who know DNS, sometime later, notice when it says the end of data, it hands it a serial number that says, this is the number, like the DNS, of the high watermark that I've just given you. Maybe later the cache says to the router, "Hey, I've got new data. You might want to ask me about it." The router says, "Well, this is the highest serial number I know so far. Got anything new for me?" And the cache says, "You betcha." Hands it some more prefixes, end of data. Very simple, very boring discussion. Notice there's no crypto in there, as you will see very shortly. Here is the reset query. This protocol is based on TLV, type length value, this entire protocol has version 0. Type of this PDU is 2, length, and there is no value. Cache response, similarly stupid. Here's an IPv4 prefix. Type, length, here's the value. The flags are, is this a new route origin authorization, or is it removing one? What's the length of the prefix? What's the prefix? Remember that macro for the maximum length? There it is. And there's the autonomous system number that's allowed to announce it. Notice there's no crypto group. The router has it pre-digested, just like a mommy birdie giving it to the baby. IPv6 prefix, 96 more bits, no magic. Same stuff. End of data, notice it does give it the serial number, as I said. So the router can come back and say, got anything later for me? Here was the notify. Here's the got anything later for me? Here's what I had, the highest number I have. Tell me anything newer. There's, of course, an error PDU. Very exciting. And that's about it. Okay, so now the router can have all this tasty stuff with all the crypto gone, and the router can just put those little thingies in the prefix tree. Now, this global RPKI, if you're running a piece of it, you would appreciate not having 100,000 people banging on it every second. So, what we suggest is that you have distributed caches, and the caches all talk to each other, and there's a they can express priority between them, etc. So some gigantic ISP might have a cache or two that are the head in Asia, North America, Europe, etc. And then in their POPs, they feed off that. And maybe like DNS, they even provide their customer with some customer-facing caches that the customer can use. So that's how to get the load off the global publication and under your control and your distribution. How do you stick it in the router? This is a Cisco. You stick it in the router very stupidly. Under the router statement, BGP statement, you say, there's a server, its IP address is, its port number is, and how often do I poll it? We're putting in very fast polls here today. This is something that shouldn't be there, but right now, the engineer at Cisco likes. He was favoring having the router make some decisions for you. As you will see in a moment, I don't like that. The result of a check in the router is one of three things. It's valid. There was a ROA, and it had the matching AS. Now remember, there could have been 5 or 6 ROAs for that prefix. One of them matched the AS. It's invalid. There was a ROA. There might have been multiple ROAs, but none of them had the same AS as the announcement. And not found. This is the incremental deployment game. There's no ROA issued yet. Okay. Of course, vendors like knobs, 25 cents a piece. You can disable the check completely. You can disable checking for a peer. You can disable checking for specific prefixes. Like when somebody does an accident out there and the note comes out on Nanog that Google just dorked their ROA, you can disable that ROA, just that ROA. When a check is disabled, the result is not found, as if there was no ROA. You can, and excuse the Cisco-isms, in a moment we'll be showing Cisco there and Juniper there. Okay, you can say, okay, you're peering with one or more caches. What's the table you've got? And this is the prefix, this is the max length. There was the length, of course. What the valid origin AS is, etc. What the neighbor is, what the cache address is that data came from. The default is origin validation is enabled if you have peered with the cache. The default poll interval is 30 minutes. And the last bullet is key. There is no effect on policy unless you configure it. It has been configured. So again, still with Cisco, show BGP blah, 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 says that AS is the valid AS to announce this prefix. So came via two routes. Okay. Here's one that there was an AS that wasn't 3927. 3927 should not have been able to announce that. So that resulted in a state of invalid. Nothing's being done, just the route is marked as invalid. Here's one that we don't know. There was no ROA in the table that matched that prefix length, max length. So its state is not found. Okay? So here I am, a poor innocent router down here at the bottom, a bottom feeding router in my AS. And there are three other entry points to the router who are hearing prefix P. This one's hearing it for somebody that has a bad neighbor. This one's hearing it from a perfectly valid point. This one doesn't have an RPKI cache, so it's unknown. What the heck should I do? Which do I choose, and how do I choose it? And there was much discussion in the design team, and what we came down to was you already have your policy. You already have your local prefs or your metrics or whatever. Do not overlay a whole orthogonal set of policy for this. Just blesh it with your existing policy. So the solution is to allow you to test the validity state and just in a route map with local policy, use it to augment your local policy. So for instance, if you wanted to run a network that up-prefed or left valid routes is 100, took not found routes, there was no row, and dropped them down to 50, and dropped invalid routes entirely, you could run this set. Okay? Here's a paranoid. If it's valid, pop up the preference. If it's invalid or unknown, drop it on the floor. We have we know at least one very large network that does not use local pref. They prefer to have path length rule. And so what the metric they twiddle is med. So they set metric and path length rules, but if equal paths come, they prefer valid. Each to their own taste. That's the purpose of the exercise. We have a friend and coworker, Steve Bellevin, who's a security researcher. He only wants the invalid ones. Right? So, different strokes for different folk, and you get to decide. Okay? And so, we have an open test bed. This slide's rather old. ISC, Google, BWC, that's Warren. And I think level 3. A bunch of folk have been playing in it. UU. And it's an open test bed. And you too can play. The RIRs have been telling us for years that they will never control internet routing. Yeah, well, you get your certificate from them, or not. That certificate has an expiry. So there's a matter of RIR policy, working with the RIRs to get this so that it's useful, and they're playing, but they're not threatening us. And that's been an ongoing negotiation, and you should participate in your RIR of choice. But the problem at the root, address allocation is hierarchic, right? So if you want to be able to authoritatively state who has the right or ownership or whatever the politically correct term is this week to that prefix, it comes through that allocation hierarchy, which is IANA to the RIRs, to the, is it fashionable to call them LIRs in this region, or ISPs or whatever? And that's life in the big city. Okay? So at least you have some influence on the RIRs. You know, I don't think I'd trust VeriSign, who took Microsoft out. So I think RIRs are the best compromise, and we just have to work with them and align attitudes. Here's another problem. We'll call it UpChain Expiration. Here's my poor innocent ROA down here and my poor innocent certificate, and some sloppy admin up above. Cert is soon to expire. Okay? Now, note that these are not identity certs. These are just the name of the cert, the subject name, if you care about RPKI terminology, is randomly generated. Yeah, right. It's a hash of the public key, as Rob says. Very intelligent. So I don't know who the hell that is. Okay? My cert, and so there, that's 2 weeks from now. That cert's due to expire in 2 weeks, and there are tools for letting me know that. So the ROA will become invalid. The ROA will become invalid, but my announcement will become not found, not invalid, because there'll be no ROA. But of course, if my parent, the one who has the bigger prefix, has a ROA outstanding, then that will cause trouble for my routing. Okay? So, Mike, floor mic? No, Rob, Ron, just stick there. He's on it. Talk.
Oh, okay. There's a flow of trust downstream in that chain that you just showed. You'd assume that there's a flow of money.
Well, no, the trust unfortunately goes up.
Okay, trust going upstream. You'd assume
money flows down. Money flows up, trust flows up.
Yes, money also flows up. And if the guy at the top gets sloppy, you'd think the money would stop.
So, anyway, oops.
I was just going to clarify something. Yeah, to a first approximation, yeah, you're right. One of two things is happening in that scenario. Either the person right above you who has the ROA that's going to take you out is also about to be taken out because it's their parent or someone upstream from them who screwed up. Okay, in which case that might get their attention. They might do something. Actually, their ROA would go away in that case, right? The other case is they're the screw up. In that case, well, you know, once you've found them, you know who to talk to.
No, that's the problem. I know that certificate's bad or going to go bad in 2 weeks, but who do you call? Ghostbusters. There's a draft on a record called a Ghostbuster record that this would sign. This is this person attesting to their identity. It is not this person attesting to this person's identity, so it's not doesn't raise all the legal issues of identity certificates. And a Ghostbuster record is essentially an abstract, in IETF terms, a profiled V-card that can have a human's name, their organization, their phone number, their email, and that's it. We didn't want to go the embellishment route. We just want to be able to contact them. Okay? So when I see somebody 5 levels up the chain who's about to cause me trouble, I should be able to call them. Okay? But in the end, you control your policy. Announcements, and this is from, there's a draft called Origin Ops, the operational considerations for origin validation. And it says announcement with invalid origins, and these capitalizations are IETF gloop. may be used, but should be less preferred than those with valid or not found. But the argument says, if I don't reject invalid, what the heck is all this for? So there's a balance there. You get to choose your own policy. I would tend to reject invalid. Sorry, Ed?
You don't like the clever people.
Yeah, I don't like the clever people. No, I don't. Okay. If you're interested in playing with the running code for the RPKI infrastructure, the certificate generators and the cache stuff and the GUI and all that we're going to get to play with next, then that's all available at this wonderful URL. Okay. Yes, that's a self-signed certificate, sorry. And there's test code in C&J routers, and you can talk to your various C&J contacts as you wish. And you should know that this is a conspiracy. The Department of Homeland Security and Aaron essentially paid for all the public source, open source RPKI software. The Department of Homeland Security, who takes your scissors away, which we then turn into plowshares, funds the open source work so that the internet's a better place. And this has been very kind of them. Aaron and a whole bunch of folk have donated all sorts of resources. And that should be the last slide of this. A little discussion, a little break. Good morning. Pardon? I know it's afternoon, but nobody here is acting like it. Yes. By the way, this is bad. Could you say who you were? Well, I'll do it. That's John Heasley of NTT. This was Rob Austein of ISC. I'm Randy Bush of IIJ. We should know, sorry, both Nanog and the IETF tradition.
So Tom Daly from Dyn. Want to understand the bootstrapping problem where, let's say there's some global failure of the RPKI subsystem for whatever reason. Let's just say it happened. And routes, the RPKI system needs to be rebootstrapped. Now, in that situation, if I understand correctly, routers should default to a not found condition because it's not in the PKI, and routes will still be in place. Is that correct?
Yep.
Now, if your own local policy is so strict that you decide that not founds are essentially going to be dropped from your routing table, you basically choose to poison yourself.
Those people probably smoke cigarettes and do other dangerous things.
Okay. Thank you.
I think, this is good. Just for incremental deployment over the next N years, we're going to be routing on not found. It's the invalids that are things that should I accept invalids? I really think not. But you may want to. And I think we're going to learn. By the way, RIPE currently, that's what I should do. Let me go through the next one quickly. It's a quickie. And this is the current state of deployment. Oops, there it is. There's this one. Right. This is the current state of various development efforts. Okay, the vendors, iOS has pretty productionist code in test. I'd call it alpha production code in test. XR has prototype alpha code in very limited test. Junos has production alpha code in test. See your account team or your inside contact at Cisco. For a fee, oops, sorry, Ron.
Randy, You talked about...
Who are you, Ron?
Oh, I'm Ron Bonica. I'm still Ron Bonica. You talked about this being incrementally deployed, and for years we'll be routing not founds. It seems like an immediate benefit would be to publish in some machine-readable form a list of all the invalids. So if you see a prefix that you really care about pop up on the invalid list, you can jump up and down, even if you don't have this in your network
We are
yet.
in the middle, somebody from Juniper, somebody from Cisco, and Bert Weinen and I are in the middle of doing the MIBs. And one of the pieces is the addition to the BGP MIB, so that for prefix, you know the state, so you can easily suck the MIB from your router, pick out the invalids, and do whatever screaming you want to do about it.
Now,
You'll see when I get to the Juniper current CLI that I can also ask the CLI, tell me all the invalids I've got.
what I was thinking is something like, let's say Steve Bellovin is the first guy in the world
What's
to implement
invalid to me may not be invalid to you. You may have a different view of the RPKI. There's two things here I didn't go into, and let me go into them. Remember that trust anchor? Well, what happens if I have a whole infrastructure inside my network where I'm stealing some prefixes from the Department of Defense, who never publishes them anyway, and have RFC 1918 space, etc. And so for my cache sucker, I'm going to have two trust anchors, the IANA and this one. And Steve Kent, to satisfy the strange, well, our strange perception of what we think the Chinese perceive, they may want to edit things. So he has an internet draft called local trust anchor, where I can have a separate trust anchor which links down to the real stuff and edits it. So you can have multiple views. My point is, I'm not interested in that last one. I think it's kinky. But I think you are going to want to deal with RFC 19 private space at the same time you're dealing with public space. So you may have two trust anchors. That means you can have a different view than I. Therefore, something I considered valid, you might consider invalid. So there's no globally correct valid and invalid. Let's finish up.
Well, it seems that 99% of what we're talking about is stuff that's anchored from IANA.
Yep.
And then there's 1% of perversion. If you leave out the kinky stuff, wouldn't it be beneficial to publish the invalids from IANA's point of view?
Yes, we're giving you all the tools to do so.
Oh, okay.
You're giving, my first answer was, we're giving you the tools to do so.
Mm.
But there's no, we're not doing it for
Yeah,
you. IANA is not in a position to do that.
Yeah,
Who's in that position? You are.
Yeah.
Rob Austein, ISC. Just one more clarification on this. Keep in mind that the stuff that's interesting in terms of invalid is actually a combination of what you're seeing in BGP as looked at against the ROAs. Okay, just looking at the ROAs doesn't tell you what invalid routes are being announced. You got to look at what routes are being announced, compare them to the RPKI, and say, I found this. But then you get into all the, BGP monitoring projects. Okay, pick your favorite monitoring project, their view of BGP. You've seen this story
As Bill
before.
Manning says, there is no global view of the internet. Sorry.
Hey, Randy, Joe Gersh from Secure 64. Two questions. One is, and I'm kind of new to this stuff, but do you have any slides that show how, since this is an incremental rollout, how this would limit the damage in case of us trying to steal prefixes, and how some areas might get stolen but others would be prevented? So it shows some attack vectors. And then the second question is on just the publication of all these certificates. Why aren't they just published in the DNS since it's a globally accessible database? Why not just get it from there? And that may have been discussed.
There's a
I'm
reason
not familiar.
people are laughing. Let me hit them one at a time.
I appreciate
No. They're not laughing at you. They're laughing at me.
Oh. Or we can laugh at
I
me too,
published
don't
an
mind.
internet draft in 1998 describing how to do it with the DNS.
Okay.
And there were reasons it was shot down.
May or may not still be valid.
Hit me with the first question again. I lost it.
Just how it limits the...
Got it. Tuesday,
damage.
I will present this This is origin validation. Then we'll do path validation, which I'll present Tuesday. We call it DNSSEC. BGPSEC, sorry. And after me, Sharon Goldberg will make a really interesting presentation on how she sees both the economic and technical pressures which will cause the deployment in what kind of patterns.
Good.
That's not this.
But it's close.
That's the other. This is interesting in that it does not require contiguous players. He can run it, she can run it, they can run it, etc. You know, I get the benefit by how many people apply it
Right.
when I publish my ROA, but I don't have to convince my neighbors to.
It'd just be interesting to see
So-
some simulations or something like that.
No, that's great, and I hope, Sri Ram, are you still in the room? Mr. Simulation's right back over there. Up there, Sharon!
Right, that's right. And on the DNS question, you'll look at that later.
Yeah, no, I'll get it to you in a second. Sharon Goldberg.
Hi, I'm Sharon Goldberg from Boston University. So last year at Nanog, exactly in June, I did a presentation on simulations of attack on BGP, and we looked at defenses with ROAs, defenses with BGPSEC, defenses with prefix lists for filtering. So if you refer to my Nanog 49 presentation, there's some of that, but we didn't do the study in incremental deployment, we did it under full deployment. So what I'm doing now with my colleague Michael Shapira, who's over there, we're actually working on a study with partial deployment as well, so I hope to have that ready for next year, but if you want to see sort of simulations under full deployment, we have that in the Nanog 49 talk as well.
Okay, thank you, Sharon. If you look back in the Internet Draft archives, there was Bates Origin Validation, I forget the name of it, send me an email, I can give it to you, where we looked at using DNS, specifically augmenting, of course, the internetter.arpa. There are a number of problems with it. The first one is that the trust model is different, right? The trust model for DNS talks about zones and who is serving them and how the signatures are between those zones. And it's different than the IP space. It's just a second piece of broken glass down here, seeing as that I'm walking in my stocking feet. So there was much discussion in the ITF and it was dropped. I can refer you to it, I can give you the draft, etc. DNSSEC was less serious then, so maybe it'll be taken more seriously, but I don't think so. Somebody brought it up again recently on the CIDR list or something like that, and nobody took it very seriously. Rob, somebody else want to? Russ, I answered this question for you a year ago. What the heck did I say? Don't worry about it.
Rob Austein, ISC. Once upon a time, I knew something about DNS and DNSSEC. There's another issue here, which is simply how much wheel reinvention is involved. It turns out if you look at the specific mechanisms that we're using in the RPKI stuff, we're leveraging on a lot of existing stuff in X509. Now, granted, X509 has an awful lot of cruft, but as with any old protocol, you can mostly ignore the cruft because there's already libraries out there that do all this stuff for you. But revocation, for example, revocation is just built into X509, and there's a mechanism for it and well thought out strategies for how to deal with this. And we would have had to re-implement all of that with DNS. We could have done it. You know, at this point, DNSSEC almost has revocation, kind of, sort of, kind of. Right, but we would have had to invent mechanisms there. The encapsulation, all the things that aren't certificates and CRLs that we're doing in RPKI are in CMS objects, which is another big honking protocol with a whole bunch of machinery that we're only using a corner of. But it allowed us to have an easy way of revoking every single one of those objects because they're all validated using an X509E certificate, so it hooks into the whole X509 mechanism, which hooks into the X509 revocation mechanism. So we get all this stuff that we would have had to reinvent. So that's part of it, is just not having to reinvent quite so many wheels. There was also the fact that people had been looking at doing a lot of this routing stuff in X509 for years. Therefore, some of the routing-specific technologies, such as the 3779 extensions, had already been done. So, it's not that we couldn't have done it in DNS. People did talk about it. People do still talk about it, but it would have been more work. And we were trying to get to a point where we could actually, compromise with people and move forward, and this is what people chose.
Which does not work. Boo, hello. Hello. I think that's interesting points, but I'm not even sure DNSSEC itself, would help, but the certificates are vouching from parent to child to themselves anyway. And as far as revocations, by just taking something out of the DNSSEC, you don't need large revocation lists. The chain is broken. Is that the part that I'm confusing? So it just seems like it would be simpler, but again, you guys have studied this.
Just a sec. Stop right there. Are you telling me that there is something, that DNSSEC is simpler than something?
No, I didn't say that. No. I said
Good.
It's simpler to have the certs vouch for each other in a chain through DNS, and taking a cert out of the DNS. It just seems simpler. And DNSSEC could provide more protections. I'm not saying it's a necessary part of this. I think the Dane working group has done some interesting look at this. So.
It is.
Okay, to answer at least one specific point there, yes, there is a difference between just removing something and revoking it. One of the things we've got specifically in the implementation that I'm working with, but I think the other validation implementations may have done something similar. We thought a lot about how do you deal with, you're gathering all this stuff and there's a network partition. So you can't actually get to all the publication sites. Unfortunately, your routing is hanging on this. Okay, as in the internet, DNS, back up a second. We used to joke there are two global databases in the internet. There's DNS and there's BGP. Okay, when DNS doesn't work, people have a hard time getting to Google unless they know how to type IP addresses. When BGP fails, there is no internet until we rebuild it. Okay, you really don't want to do things that are going to risk the routing infrastructure. But for this particular project, we had no choice, right? Because the whole point is securing the routing infrastructure. So we have to do things that are, at best, a spiral dependency. Okay, but what do you do when you have to fetch something and the network is partitioned? So the approach that we took in our implementation is that we keep a cache of what worked the last time. Okay, when you're first coming up, there's a bootstrapping problem. But once you've done the bootstrapping phase, you keep all the stuff that worked during the last validation cycle. And if there's a partition and you can't get the fresh stuff, you go back to what you had and see if that still validates. Okay? There's a big difference there between being taken out or not being reachable and actually being revoked. Okay, revoked is a definite statement that someone wanted this to go away. And at least with the kind of dynamics we're looking at here, we actually depend on that difference. Signed, we want that to go away is very different from just I can't find it today.
That's part of the trust models are different. Yep. Okay. So that's kind of the status of code running in routers. And both significant vendors are committed to production schedules. I can't speak for them, but early next year in running production. You're supposed to put it in your lab and let your lab people run it for a year before you deploy it, but okay. The picture of the IETF documents on the RPKI, it kind of looks like there's the certificate and ROA engine, and there's a set of documents for that. And then you can clap a web interface on the front of that, as I've described, so that the user can say, issue me a ROA, please. There's the up-down protocol so that you have children. Both you and your children can publish in the global RPKI. So there's the up-down protocol, there's the publication protocol. Then there's arsenic to the cache validator, and there's RPKI to router protocol. And there's a bunch of other documents tucked around those. There's probably 20 documents all in all, I don't know. APNIC has a web interface to the engine and does the up-down protocol so they can have children. They don't have a publication protocol. They just have their own little RPKI on the side. RPKI service that you can fetch from, but they can't, their software won't publish remotely. RIPE just has a web interface and a local directory. No up-down protocol, no publication protocol, et cetera, et cetera. They are working on the up-down protocol, and they hope to have it sometime this northern hemispheric summer. BBN has a cache validator that's rather cool, and they're working heavily on coming up with all the kinky corner cases and breaking things. So they're generating really kinky certs and everything we can all run against on the interoperability tests, and they have what they're hoping to be a very strict validator that can see what everybody else is generating and bitch about the stuff that doesn't conform well. We being the DHS, et cetera, funded effort, Rob, et cetera, and Michael who's sitting over here, have all the protocols, all the garbage in one can. Okay. Aaron is using RIPE code and waiting for up-down, et cetera, et cetera. Afrinic is using a PNIC code. Okay. LACNIC is using RIPE code. That's the story of implementations out there. You're looking like you want to spring forth. Nope. Okay. So, let's see if I can get this right. Oh, I can't. Because, well, I'll do them one at a time then. This is embarrassing. Oh, but I have Dropbox. So, if I do that, and I do this, hello. Where is my cursor? There is an official break time? Wow, psychedelic. Okay, let's put Cisco over there. So it's clab.pptx. And let's put Juniper over here. Okay. So we're going to do a hands and feet on lab, which will be Cisco over here and Juniper over there. And if this sucker will come up, Dropbox is great, let me tell you. Microsoft isn't. There we go. Oops. But this is what I gave a couple weeks ago in DAR. Sorry, but it's the same. Okay. What we have, and this is true for both of them, is we have, where's the lab overview? There we go. So, in both cases, we have a nice GUI, which is in Django by Michael over here, that talks to an RPKI engine that is actually in the Westin in Seattle. It publishes somewheres in one of our servers. There's the gatherer, which is in Ashburn, and it makes RPKI to router service available over the internet. Now, of course, this is ill-advised because this link in the protocol is not authenticated. The RPKI router protocol is not authenticated, so we really should be running it in POP, but you'll find out we're running Cisco routers with the password Cisco, so what the heck. Okay. We have in both cases a lab. The lab in Juniper has 2 border routers, and it's connected to 2 real feeds, and 98.128 is what I'm giving you from 3130 and 4128. And the reason we have 2 is so one can be the attacker and one can be the valid one. Okay? And the 2 worlds are very similar. There's the external sources of prefixes. There's the 2 border routers in the lab setup. In Junos, we have a virtual server that is serving about 30 virtual routers, the 2 border routers, and a bunch of, quote, student routers, which you can play with. And the reason we have both 2 borders is we want to give each student router 2 feeds, one valid, one invalid. Okay? And if there was only one border router, it would choose best path, and this would only see one path. So you want to see 2 paths, which you do. And you'll set up peering with a cache. Okay, so you get the table feeds, and so forth. Now, what you should know that's critical here is this, we decided this about 4 months ago, is the global internet is pink. I know you never knew that, but now you do. It is officially pink. It's mauve, actually. Pardon? The colors don't match on the 2? I can't help that. That's projectors and all that stuff I don't know much about. Okay, so we have experimental allocation from Aaron 98.128/16. And we slice it up into 24s. And so lab user 1 will have 98.128, 1, 2, da, da, da. I'm sure you can figure that out. Okay? And there's a GUI. And you have GUI accounts. Oops, this should have been fixed and it wasn't. Lab user 1 through 32. Okay? So who here actually wants to play with routers? Come on, get those hands up. So enough people have to do it to make it interesting. Uh-oh, we're gonna have fun. We're gonna see Russ play with a router. These routers are connected to the global internet. And the router through which they connect drops all their announcements on the floor. And that has been tested. Okay? But okay, so get your hands up and pick lab user numbers. Let's take 1 through 16 can be used for Cisco's, and 17 through 32 can be used for Junipers. So, and we'll run them all at the same time. Who wants to be, let's take the Cisco's. Lab user 1. Fight it out. Do you either work together? 1, 2, all you got to do is remember 3. Okay, you're Cisco. 4. Ooh, 5, 6. Remember what you got. You've got to remember. 7, 8 back there. Did you already have a number? No. Okay, you've got 9. Woo. 10. It's 3 wrong. Okay, remember your number because you're going to have a router with that number and a prefix with that number and a lab user account number. while you're keeping from getting bored, log into the GUI with your lab user number. Junipers, 17. 18. Frank, 19. Come on, Ron. You're with him. Oh. More junipers. Okay, only 3 of them. Okie doke. So, oh, wow. This is really old. Yeah, this is old. That's a shame. Okay, so go to the GUI, and you can take a look at the GUI, and you have a prefix. If you log in as lab user 92, you should find you have 98.128.92.024 allocated to you by your parent RGNet. Do all the lab users? Which lab user are you? 19. 19, you're a Juniper. Michael?
Try clicking refresh.
Refresh? Pardon? 21? 19 and 21, please. Pardon? You don't have a parent? How sad. How sad. Would somebody adopt him, please? Poor Warren. He's just running for cover. You're welcome to pair up, by the way, to get help, to find somebody to commiserate with you if you're an orphan. Do you think you're not on a router, you're just on the GUI. Well, let's go slow. Let's see what. Well, start allocating then. Okay, we have a manual error. We'll deal with that in a second. So what would actually happen? Let's skip that for a second, and let's go to your router while they clean up the GUI. Pardon? It's about break time. Okay. The people with the GUI would like us to declare a break so they can quickly. Just saying, break. Are they going to give us snacks this break? I doubt it. Not on Sunday. There's snacks out there. What's more important, routers or cookies?